Hey, it's graphical inequalities. So we got to draw these, shade the region or label the region that's satisfied by all of these inequalities in two dimensions. Well, the first thing to focus on is getting the equation. So y equals 3, y equals x, and x plus y equals 9. Just need to take into account the inequalities as we draw them. So y equals 3, well, that is this horizontal line. Everywhere along here, y is equal to 3. This is 7, 3, this is 6, 3, this is 5, 3. It gives you a horizontal line. Just going to get rid of those crosses though, because actually it's not actually allowed to equal 3. So what we must do is we must do a dashed or dotted line to represent that inequality. And there we have it. I might as well deal with it as we go. So because it's y is greater than 3, it's going to be the points that are above this line. Okay, so you must recognize y equals 3, that it's a horizontal line. You must make it dotted, and then I've just gone for looking at the region above the line already, but I'm not going to shade anything because that's just one of the lines. The next one then, y is equal to x. This time it can include x, and this is your classic y equals x. It goes through the origin, and basically everywhere along the line, y is equal to x. We've got 10, 10, we've got 9, 9. The other way of thinking about it is that it is in the form y equals mx plus c, because it's 1x plus 0, so it goes through 0, and my gradient's 1. I go along 1, up 1, along 1, up 1. And I'm interested in y is greater or equal to x. So again, it's got to be above this line. Okay, finally, we're left with x plus y less than or equal to 9. Two ways to do this question. First way is to rewrite it as y equals 9 minus x. Or if you're putting it in the form y equals mx plus c minus x plus 9. So that's going to go through 9, and then I'm going to go along 1, down 1, along 1, down 1, and my line is going to have a negative gradient sloping down to the right, like so. There is another way you could have got this, and by the way, I include 9, so it's another solid line. Another way you could have done this question is that you could have done the cover-up method where you just let x equal 0 and figure out what y must equal. And remember, we're setting it equal to, so x plus y equals 9. If x is 0, y has to equal 9, and that gives you that point here. And then when y is 0, we have x plus 0 equals 9. We must get that x is equal to 9, and that gives you this point down here. This is an effective way of drawing graphs when you have like an x minus y equals a number or x plus y equals a number. But I decided to do it by rearranging, but I also just thought I'd show you that way. To work out the region, it actually does help to rearrange it. So it's going to be y is less than or equal to 9 minus x. So this time it's going to be the points below the line. If you don't want to rearrange it, then you can pick a point and see if it works. So for example, 0, 0. 0 plus 0 is less than or equal to 9, so I know this is in the region for the red line. Whereas if I tried 10, 10, that's 10 plus 10 is not less than or equal to 9, so I know this one doesn't work. That's just another way of thinking about it. So I'm basically there. I just need to put the regions together. It's got to be above the black, above the blue, but below the red. And here we go. This is going to be the line. Sorry, the region. And it's asked me to label it R, so I've shaded it as well. I think it's a good idea to shade it, but I'm also going to label it R.